Multiple Stress Creep and Recovery, MSCR, Implementation and Transition. This presentation was prepared by Galen Baumgartner under the Development and Deployment of Innovative Asphalt Pavement Technologies Cooperative Agreement with the University of Nevada, Reno. Presenting today are Galen Baumgartner of Paragon Technical Services, Inc., Jackson, Mississippi, and John D'Angelo of D'Angelo Consulting, LLC, Annandale, Virginia. This material is disseminated under the sponsorship of the U.S. Department of Transportation in the interest of the information exchange under cooperative agreement number listed. The U.S. government assumes no liability for the use of the information. The U.S. government does not endorse products or manufacturers. Trademarks or manufacturers' names appear in this material only because they are considered essential to the objective of the material. They are included for informational purposes only and are not intended to reflect preference, approval, or endorsement of any product or entity. This presentation is arranged into 8 sections corresponding to the major headings of the Companion Multiple Stress Creep and Recovery, MSCR, Implementation and Transition Technical Brief. First, a brief introduction will be presented, followed by a section on background information. Section 3, Overview of the Superpave PG Specifications, discusses AASHTO M320 and AASHTO M332 with comparison of similarities and differences. In Section 4, improvements offered by AASHTO M332 are discussed. Section 5, Barriers to Implementation, presents the 5 common reasons for delay in implementation of MSCR and transition to AASHTO M332. Section 6, Implementation of MSCR transitioning to AASHTO M332, offers 6 easy systematic steps to aid in implementation and transition to AASHTO M332. Section 7, Status of Implementation of M332, presents an overview of the status of implementation in the U.S. and/or user-producer group regions. In Section 8, AASHTO M332 examples, Dr. John D'Angelo will provide examples where and how M332 specifications may be used under special conditions and special needs. We'll begin with a brief introduction. Currently, there are 2 AASHTO binder specifications in use. The primary objective of this webinar and the companion technical brief is to assist deployment and transition from AASHTO M320 standard specification for performance-graded asphalt binder, also known as the PG binder specification, to AASHTO M332 standard specification for performance-graded asphalt binder using multiple stress creep and recovery MSCR test, also known as the MSCR PG binder specification, and sometimes affectionately known as the massacre specification. Additionally, technical information on the background of the MSCR test and the AASHTO M332 specification will be presented with a discussion of implementation activities. This project is sponsored by the Federal Highway Administration Project Development and Deployment of Innovative Asphalt Pavement Technologies, specifically related to deployment and technical support of MSCR binder specifications. An accompanying technical brief entitled Multiple Stress Creep and Recovery, MSCR Implementation and Transition is also available. A brief background and comparison of both AASHTO M320 PG binder specification and AASHTO M332 MSCR PG binder specification is in order. The early 1990s saw the advent of the Superpave performance-graded PG binder specification, AASHTO M320 standard specification for performance-graded asphalt binder. A product of the Strategic Highway Research Program, the PG binder specification was first introduced as a provisional specification for implementation through the various asphalt user-producer groups. AASHTO M320 was introduced as an acceptance specification in the late 1990s. The primary parameter of the upper grading limits in M320 is G star divided by sine delta. Slightly more than a decade later, AASHTO M332 was introduced as an enhancement to M320 to address PG issues with respect to permanent deformation not being adequately addressed by the G star divided by sine delta parameter. The M332 specification relies on results of multiple stress creep and recovery testing in accordance with AASHTO T350, standard method of test for multiple stress creep and recovery, MSCR test of asphalt binder using dynamic shear rheometer DSR, and a well-established creep and recovery concept. M332 captures the non-recoverable creep compliance JNR and percentage recovery from AASHTO T350 testing. Originally, MSCR was introduced as a provisional specification in 2009 and was incorporated into AASHTO M320 as a Table 2 and later as an optional MSCR standard AASHTO MP19. In 2011, AASHTO M332 was provided as a standalone specification. The primary parameter for high temperature grading of PG binders with AASHTO M332 is JNR, the non-recoverable creep compliance. Overview of Superpave PG Specifications. AASHTO M320 and AASHTO M332 are similar in several ways. Both cover asphalt binders graded by performance-related criteria. Binder specification limiting parameters are based on rheological properties of asphalt binder measured over a range of temperatures and aging conditions. Grading designations are established based on accumulated degree days above 10 degrees C to determine high pavement design temperature and a minimum pavement design temperature. Typical PG binder grades are specified for climate conditions ranging from high temperature grades of PG 46 to PG 82 and low temperature grades ranging from -10 to -40 degrees Celsius. The primary difference between M320 and M332 relates to how traffic speed and loading parameters are addressed. M320 incorporates grade bumping through adjustment of the high temperature grade of the binder. Climate temperature does not change, only the temperature at which the high temperature grade testing is to be performed is bumped to account for traffic. M332 relies on non-recovered creep compliance JNR, with JNR determining the suitability for standard, heavy, very heavy, and extreme heavy traffic loadings. There is no temperature bumping in M332. All testing is performed at the regional LT/PP bind climate temperature. Naming of asphalt binder grades is handled differently between AASHTO M320 and AASHTO M332. M320 uses the familiar nomenclature of performance grade PG, followed by the high temperature limit including bumped temperature, and the minus sign for negative low temperature grade limits. For example, an LT/PP bind 64 degrees C regional climate temperature bumped to 76 degrees C high temperature limit for heavy traffic, and a -22 low temperature limit would be named PG 76-22. M332 nomenclature uses the performance grade PG designation followed by the high temperature LT/PP bind regional climate temperature, no temperature grade bumping, followed by either S, H, V, or E for standard, heavy, very heavy, or extremely heavy traffic. Grade bumping is accounted for in the specified JNR limits, and the minus sign for the negative low temperature grade limits. For example, the same PG 76-22 in a 64 degrees C LT/PP bind climate, as in the example given, would be named PG 64H-22. Original non-aged asphalt binder properties for both M320 and M332 are tested and specified the same with a minimum DSR limit of 1.0 kilopascals. The primary difference between the two specifications is again with the testing temperature. M320 asphalt binders are tested at the high temperature limit, which is determined as the LT/PP bind regional climate temperature plus any temperature grade bumping required by AASHTO M323 standard specification for Superpave volumetric mix design. M332 asphalt binders are tested at the LTPP bind regional climate temperature, no temperature grade bumping. It is important to note and understand that ODSR, original DSR results from M332 H, V, and E grades will be considerably higher than results from M320 temperature grades approximately 2, 4, or 8-fold respectively. Temperature bumping M320 and JNR M332 grade bumping should not be combined, as this will require overly stiffened asphalt binders. This table presents a comparison of AASHTO T240 rolling thin film oven RTFO H binder according to M320 and M332. M320 incorporates testing of asphalt binders at temperatures appropriately bumped to account for traffic, with AASHTO T315 standard method for test determining the rheological properties of asphalt binder using dynamic shear rheometer, DSR. DSR G-star divided by sine delta limits set the minimum of 2.20 kilopascals. AASHTO M332 does not specify RTFOH G-star divided by sine delta limits. M332 relies on MSCR data from AASHTO T350 testing of RTFOH asphalt binders at LTPP bind regional climate temperature with no temperature grade bumping. Traffic speed and loading are accounted for with specified JNR maximum limits of 4.5 kilopascals for standard traffic, 2.0 kilopascals for heavy traffic, 1.0 kilopascals for very heavy traffic, and 0.5 kilopascals for extremely heavy traffic. Again, all M332 MSCR testing is performed at the LTPP bind regional climate temperature, no temperature bumping. JNR limits account for the traffic frequency and loading. This table presents a comparison of AASHTO R28 pressure aging vessel PAVH binder according to M320 and M332. Both M320 and M332 require PAV aging based on regional simulated climatic conditions at either 90, 100, or 110 degrees C. Both M320 and M332 intermediate temperature limits are determined as half the differential of the maximum and minimum pavement design temperatures plus 4 degrees Celsius. Currently, all M320 PAVH specimens tested at specified intermediate grade temperature are limited by G-star times sine delta to a maximum of 5,000 kilopascals. Of important note, effective with publication of the revised standard of AASHTO's standard specification for transportation materials and methods of sampling and testing with AASHTO provisional standards, 41st edition, to be published in July 2021, M320 asphalt binders that have a G-star times sine delta value from 5,001 to 6,000 kilopascals will be considered acceptable if they have a phase angle of 42 degrees or greater. M332 PAVH specimens tested at specified intermediate grade temperatures for S grade binders are also limited by G-star times sine delta to a maximum of 5,000 kilopascals. Again, note that with M320, S grade binders that have G-star times sine delta values of 5,001 to 6,000 will be considered acceptable if they also have a phase angle of 42 degrees or greater. M332 PAVH specimens tested at specified intermediate grade temperatures for H, V, and E grade binders are limited by G-star times sine delta to a maximum of 6,000 kilopascals. The reason for increasing the maximum G-star times sine delta is that the calculated intermediate test temperature will be lower since the upper grade temperature limits were not bumped. No temperature grade bumping. Upper temperature testing is at LTPP bind regional climate temperature. Remember, intermediate test temperature is determined as half the differential of the maximum and the minimum pavement design temperature plus 4 degrees Celsius. Both M320 and M332 PAVH binders are tested for low temperature specification limits using the bending beam rheometer, BBR, in accordance with AASHTO T323 with stiffness S values limited to a maximum of 300 megapascals, and creep slope M values limited to 0.300 at 60 seconds. Test temperatures are established as 10 degrees C below the LTPP bind minimum pavement design temperatures for both M320 and M332. Improvements offered by AASHTO M332. The AASHTO M332 MSCR specification offers several improvements over the M320 PG grading specification. First, JNR is better correlated with rutting potential than G star divided by sine delta. Second, MSCR test results for modified and unmodified asphalt binders can be determined with the same test procedure, eliminating the need for additional tests such as PG Plus tests to characterize high temperature performance of modified asphalt binders. Also, JNR diff limits offer a criteria to eliminate rutting susceptible overly stress sensitive binders which are not captured by M320. The percent recovery from the MSCR test does a better job of characterizing polymer modified asphalt binders, as well as being faster and easier compared to other PG Plus tests like elastic recovery. Lastly, MSCR testing is conducted at the actual pavement temperature regardless of the traffic loading. No artificial temperature bumping. This table gives an example of the correlation of the non-recoverable creep compliance JNR to field rutting performance from a project in Mississippi. The data confirm the utility of JNR as an indicator of an asphalt binder's resistance to permanent deformation. This figure exhibits stress-sensitive binders to show the importance of the JNR diff specification limits in M332. The wax-modified binders represented in this figure have very small JNR values at 0.1 kilopascal level, but at 3.2 kilopascal lose significant stiffness. This wax study was one of the drivers to include JNR diff in the binder specification to limit the types and amounts of waxes that could be used to modify asphalt binders. Next, let's discuss MSCR percent recovery. The figure on the left presents the MSCR percent recovery specification limit curve from AASHTO T350. MSCR percent recovery does a better job of characterizing polymer modified asphalt binders, as well as being faster and easier compared to other PG Plus tests like the elastic recovery. The MSCR test also provides an alternative PG Plus test to identify the presence of polymer. The figure on the right presents the specification limit curve from AASHTO T350 compared to results of several different modified binders tested at different temperatures, 58, 64, 70, and 76 degrees Celsius. Dr. D'Angelo will discuss this further later in this presentation. Let's discuss the 5 common barriers to implementation. Discussion with various state DOT materials engineers have revealed some potential barriers to state DOTs implementing the AASHTO M332 specification. These include, first, status quo, satisfied with current practice, possibly limits of staffing and return on investment. Some agencies have expressed concern that implementation could exceed existing staffing capabilities, limiting the benefits and cost effectiveness of the implementation. Second, agencies' fear of change and the desire to get the same products they've used historically. With any specification change, there is no guarantee that materials can be expected to stay the same. One key way to account for this is to thoroughly test the material using both specifications. Third, industry suppliers may fear grade proliferation. Agencies may work with suppliers as they have in the past to establish which grades are needed and typically used in any geographical location. Fourth, specification name change and training. One issue here may be costs associated with transition. This is standard procedure for many highway agencies. Updates and added new specifications are continually made to agency specifications. New special revisions are continually added in training, updated. Use of electronic documents have made it quite easy to do these updates. And then fifth, loss of grade bumping options. There's not an issue in the AASHTO M332 specification. This is not an issue in the AASHTO M332 specification. The grade of binder is changed based on J&R compliance value opposed to testing at different temperatures. And Dr. D'Angelo will also talk about this later in this presentation. Implementation of MSCR transitioning to the AASHTO M332 specification. The Asphalt Institute Technical Advisory Committee prepared a document for the asphalt industry users and producers regarding the implementation of MSCR test and specification. In this document, 6 simple systematic steps are provided for implementation of MSCR test and transition to AASHTO M332. First, familiarization with the MSCR test. Second, familiarization with the M332 specification. Third, perform transition testing as necessary. Fourth, transition regionally and uniformly. Fifth, apply the MSCR percent recovery as necessary. And sixth, eliminate existing PG plus test. This can be accomplished over time with limited parallel testing if necessary. Next, we'll have a quick overview of the status of implementation of AASHTO M332 in the U.S. As of the fourth quarter of 2019, implementation and transition to AASHTO M332 in the United States consisted of the following. 13 states are currently using AASHTO M332. 15 states are using AASHTO M332 for PMB only, for polymer modified binders only. 3 states are using AASHTO M320 with AASHTO M332 percent recovery as a plus test. 19 states are still using AASHTO M320 and other plus tests. At this point, I would like to introduce Dr. John D'Angelo of D'Angelo Consulting to complete the remainder of the presentation and give some examples to consider in implementation and transition from AASHTO M320 to AASHTO M332.
Thank you, Galen. Really appreciate the introduction. And I'd like to now go over some of the issues and important nuances of the AASHTO M332 MSCR specification. When we talk about the specification, the recommendation is that you select a binder based on the environmental grade. However, that's really set for when you're using a binder, selecting a binder for rutting and what will be used, in the mix to address rutting. However, there's been some concern. People say, well, what if I want to use a different binder, say for wrap? How do I use the M32 when I'm supposed to use the environmental grade? Well, just like in the M320 specification, it said the same thing, really. You're supposed to select the grade, based on the environment, and that had to do relate to rutting. Well, with the M332 specification, for example, when you're going to use high levels of wrap and you want to use a softer based asphalt to blend with the wrap, you can do that also with the M332 specification. For example, if you were using a 64S as a typical environmental grade and you're going to use higher percentage of wrap, you could use a 58S grade. So, that is a completely acceptable thing to do. Also, in some cases, highway agencies are more interested in cracking issues. And maybe, rutting has not been an issue because they have got extremely good aggregates, using certain types of mixes that have very little rutting issues. But they are more concerned about low temperature cracking or durability cracking. Again, then you could select maybe a different grade. Instead of a 64 E grade, you might want a 58 E grade with a lower low temperature property. So, highway agencies have always selected binders based on what best fit their type of mixes, the type of traffic, the environment they're dealing with. We in the specifications we make general recommendations on how the general populace can use a specification, but there are always specialty instances, and the agencies can make modifications to address their unique experiences and issues with the specification, whether it's M320 or M332. This can be done. So let's look at a little bit, some of the issues and properties of the M332 specification. When we originally developed the specification, we looked at a lot of existing binders, and we tested them in multiple temperatures to see, what they looked like and what the relationship was in the MSCR specification as compared to the M320 specification. And so you can see here several 70-28 binders made with different formulations, and a couple of different PG 76 grade binders, again with 2 different modifications. Now, just to have a little bit better way of looking at this, we want to show you this exact same data. However, in this case, we plotted it on a log scale for the JNR value, and it's a little bit easier sometimes to see how these materials look different. A good example would be the 2 PG 76 grades. Here's a 76-22 made with SBS, and here is a 76-28 made with Alveloy. Now, at 76 degrees on the testing properties, they're both basically what we call 76H grade. But they have, very different recovery properties. And as we go down and lower the temperature, either it's 70, 64, or 58, now you can start to see the JNR values start to separate out a lot more, depending on the base asphalt, because 76-22 is going to use a little bit stiffer base asphalt than the 76-28. And then you'll start to see that. So where you have almost the same JNRs here, they start to now separate out at a little bit colder temperatures, and the percent recoveries start to come together. Now, if you look at the PG 70 grade binders in the M320 grade, you start to see some very big differences between these properties. With the JNR values, at 76 degrees, for example, this SBS alveolar combination wouldn't even be an S grade. It's not till you drop down to 70 degrees you start to get an S grade. Whereas this 70-28 alveolar, even at 76, is an S grade. So it really shows that this how the base asphalts and the formulations make a big difference, and the M332 specifications really start to show some of these differences. And again, these are based off of existing asphalts that were used on roadways back in the early 2000s. One of the big questions that's been brought up about the specification, especially the M322, when you start to look at, how does it affect these when you use softer base asphalts, what happens to these binders? And again, it's the same thing that we talked about earlier. It really has a significant relationship to the base asphalt, and if it was modified, the type of modification and the processing that went on. So here you see several different materials, 5828, 5834, 6434, 5828 here, this particular min road material. We see that there's percent recovery is 0. So even though it was a non-modified binder, at 58 degrees, the J&R value said, well, it's a little bit stiffer, it's been an H grade, but there's no polymer modification. Whereas if you look up at this 5828 here, this was specifically designed to be a polymer modified material. So we have the exact same, very close, within a couple of degrees, M320 specifications. But now you can see here, the percent recovery, is now significantly higher at 28.2%, even though it's still a 58H grade. And, again, you see these two 6428s. One is a 64S, and one's a 64V in the MSCR specifications, where they had very, very similar M320 continuous grades. But you can probably see why this might have happened, why you go from an S to a V grade, because when we look at the percent recovery of this particular one, you see that this is significantly higher for this 6428 as opposed to this one. So this probably had a significant effect, increasing or decreasing the J&R value, and increasing the overall stiffness of the binder, so that in the M320 specification, you would think you were getting the same material, and the M320 is showing that there is a pretty large difference between these materials. And again, the same thing between this 5828 here and this 5828 here. You can see that there are some significant differences between these materials. And that's why it's important that when you transition from one specification to the next, if there is some specialty binders that you like, or there's something that you've been using all along that you particularly feel has been giving good performance, you need to make an initial comparison to see what those materials look like in both specifications, so that as you switch over to the M332, you can specify it based on what you want and try to get similar types of materials. And that might require that instead of using a 58S, in this case here, we use 5828, you want something with a polymer modification, a little bit stiffer, you use an H grade instead of just an S grade, and you would put a percent recovery requirement on it. Whereas this particular neat asphalt here, okay, it's still an H grade, but no recovery. And so you would not, if this is the one you wanted, you would not specify a recovery. But if this is what you wanted, you would specify a recovery. And just to show you a little bit why there's a difference here, two different binders. One's a 5834 and one's a 5828. And I picked these two because they have similar high temperature grades, but they're very, very, very different. You can see that in the creep and recovery response. The 5834, you can see when it's loaded, it has a higher deflection. But then when the load is removed, you have that recovery, giving you that delayed elastic response, showing you have some kind of polymer modification. But even so, they both end up in about the same place, which is, in the end, what we want for address rutting. But here, this shows you the clear indication that you had the polymer modification is something different. So in the 5828, you load that binder, it deflects, but now it's primarily in the viscous mode, which is what we expect, based on, all the grading we've done. And so now there's no recovery. It deflects. It stays in the same location. And so we have the same rut resistance of these two materials, but very different, say, cracking or durability responses. In this case, I wanted to show you some binders. In this, we have very similar J&R values, but again, the percent recoveries are very, very different depending on how they originally were specified. And then again, these are from different types of specifications. These were specifically designated to be polymer modified. This was not specifically designated to be polymer modified, but to get to the -34 grade, they had to do that. So you can see that they all came out to be 58 H grades. The J&R values are all in that H range between 1 and 2, less than 2, but greater than 1. But there is a significant difference here. Is this one particular one is a 0.83, which is getting close to the upper limit for that H grade, almost going into an S, where this particular binder here is almost the point where it switches over to a V grade. So there are differences, and you have to understand that when you look at how you specify these materials, and recognize that and include that in your approach to specifying the materials. And you can see here again very different percent recoveries from 0 up to 37, and again that's very much based on the base asphalt and the type of polymer and the processing that was used. And I can tell you these binders came from different parts of the country, different base asphalts, and different formulations. Here we're trying to show you how there can be some very, very big differences, both in the J&R value and in the percent recovery. In this particular case, if we look at the M320 continuous grade for the 3 binders, they're all very, very similar, all within about a degree, except this one is -34. But so you get 2 30s and a -34, but you get a 66.7, 66.2, 67.6. But when we go to the J&R values, we see that there is a big difference. These 2 particular ones are S grades. They're less than 4.5, but above the 2. This one particular 6428, though, now we see the J&R is 0.52. It's significantly less. It's almost an E grade. So that's why you have 64V. But now we take a look at the percent recovery, and it sort of gives you an explanation of why there's this big difference. Here you can see there's a significant amount of recovery in this material, and as opposed to the 22% or 24%, now we have a significant amount of recovery for a J&R value, MSCR values, and so this probably had a significant hit, causing that reduced J&R value, even though we don't see the differences in the M320 specifications. So again, it's very, very important that if this material is something you've been using and you like, don't assume that you can just go to a 64 S grade or 60 or H grade and get the same thing. You're going to have to specify a higher percent recovery and change to, say, a V grade. If this is something that you've been getting and you like, to keep getting it, you'd have to specify a 64 V grade with, say, a minimum 70% recovery to make sure that you continue to get this type of material, as opposed to, say, a 64 minus 28 with these type of properties. As we look at this, just to show you how formulations make a big difference, you see a lot of different things here. Here is a 6428. Now we have a very lower J&R value, very high percent recovery, for the 6428. But then when we drop down to the 6434, here we see that, it has very little recovery. And the J&R value is very, very different. So there can be a wide variety of different values here. And again, it's all based off of the base asphalt and the formulation. some of the similar binders here. You see them tested at 2 different grades, temperatures, 64 and 58. And if we look at these, in this particular case, these 2 binders here, this is a 5828 and this is a 5834. When they're tested at 64 degrees, they would still meet a 64S grade. However, when they're tested at 58, now they have both dropped down to the 58H grade. This particular one here, which is a 58 minus 22, at 64, you can see it doesn't even meet an S grade now. It's significantly softer, but it will meet a 58H grade, just barely. It's just at the limit, at just under 2. But it has a significant amount of recovery, meaning it was probably highly polymer modified, and that's probably why you can see the big shift that's going on here. Now, these other 2 materials here, this 64 minus 28 and the 64 minus 34, you can see that they're extremely significant amounts of recovery, meaning relatively high polymer modifications in these materials, probably a lot of cross-linking. This particular material here, you could probably get it down to a 52E grade even. But here you see it tested at 64 and 58, but even at 52, my guess is that this at 64 rather, this would be a 64E grade. Excuse me on that one. This would even tested at 64, you'd probably still get an E grade out of it with a significant amount of polymer modification. So, it's really, really important to to evaluate these materials, looking at what you've been getting, testing it under the new specifications, determining if this is the typical type of materials that you want. You have to make adjustments to that and make sure that you're still getting what you want, and that is completely acceptable under the M332 specification. We have general recommendations on the environmental grade for selecting high temperature writing properties, but that's a general recommendation that addresses most of the country, but not all the different types of materials, specifications, mixes, and conditions that the highway agencies have to deal with. So, there is a great deal of flexibility, as there was in the M320 spec. There is also in the M332 specification. With that, I'll say thank you, and I guess we open it up for discussion.